Hey everybody, David the AI Guide here. Happy Sunday. Thanks to the new subscribers this week. We really appreciate it. Also check us out on Facebook and Twitter. And today we're going to talk about robots again. We talked about them recently in the sense that robots are gaining significant capabilities physically, right? So UPS and FedEx are testing robots to see if they can sort packages at high speed and things like that. So on the physical front, robots are progressing very rapidly. And another place you can check this out is look up Boston Dynamics on YouTube and watch one of their videos from 3 years ago and one from back in December. And the difference is stunning. So this is physical improvements to robots in terms of their mobility and dexterity and things like that. But what about the way robots think? Is it possible to improve that? And specifically, is it possible to make robots be more human-like? So this was something that there was an article in Psychology Today about recently, and I'll give you the link. But in this article at Psychology Today, they were talking to a group of professors at Columbia University in New York City in the AI group led by Hod Lipson. And Dr. Lipson and his team were trying to see if by using machine learning, robots could be taught empathy. So what is empathy? Empathy is the ability to infer the behavior of others. And even for people, this is not something that can be observed. It's only a theory because, and it's called the theory of mind, and it's only a theory that humans do this, and it's a theory only because it cannot be observed to be validated. Maybe one day they'll be able to actually see it using live brain scans and stuff like that. But empathy means I am observing someone else and I can understand either what they're trying to do or what their emotional state is by observation. So they were wondering, can you teach a robot empathy through machine learning? So how would that would be done? Well, first, as you guys know, as well as anyone from all of our videos that you've been watching, machine learning requires examples, right? So this is probably a use of a neural net, although it doesn't say that, to infer, but that makes sense that it is. I'm inferring that it was a neural net from the article, and that's because neural nets are the type of machine learning that can infer things. So, without giving this AI algorithm any examples that it was trained on, could a robot watch another robot and watch that robot's behavior and predict what the long-term outcome of that behavior is? Now, that can be done very short-term, like movement to movement. They call it frame to frame. So this can be done very short-term, but was not able to be proven longer term until this study by the Columbia University AI professors. And what they were able to demonstrate was that simply by watching, one robot could learn using machine learning or a neural net to predict the behavior of another robot. You can appreciate what a breakthrough this is, at least conceptually, if not actually, because what would be one of the main impediments to putting robots in human-facing situations? It's their ability to read people and respond to people correctly. Now, there's other AI research going on, and there's other AI interfaces that have been written that do respond to people. You can see that at CES, not this year, but the prior year, 2020. And you can also see it if you look up Peter Diamandis. He was at CES and he talked to an AI. And then at one of his conferences, he also had the AI speaking to him and his audience. And so AI can respond that way, but these AIs, again, were trained in neuro-linguistic program, not NLP, sorry, not neuro-linguistic programming, that's a different NLP, but natural language processing. So these other AIs are trained in that and to be able to respond to a question. And those are now known as chatbots, and they're getting extremely good. So good, in fact, that they can trick humans into thinking that they're a live human already. Chatbots are already that good. Natural language processing is already that good, and it's being dramatically accelerated, as I said in one of my recent videos, by OpenAI's GPT-3, which was released less than a year ago. So huge breakthroughs on the language processing side. This is not that. This is watching and learning. And so this will complement NLP, natural language processing, and really get a robot to the point where it is fully human interactive. And that opens up the door to many, many things that I have said are coming. And those things include waiters and waitresses in restaurants, and they include home robots that can do the laundry, clean the kitchen, load and unload the dishwasher and the kitchen cabinets, run the robot vacuums and mop the floor, do anything you need around the house. This is all now much closer because of this work by the team at Columbia University. So things are changing very, very rapidly. And one of the interesting things is that for a long time, you only saw AI articles principally in technical magazines or computer-related magazines. And then it bled into the mainstream media. But to see research in psychology using AI in an academic paper in psychology today is very interesting, because this is proof that we are beyond the inflection point, in my view. On the exponential curve, it starts out very flat, barely gradually rising. Then you hit the inflection point like a hockey stick where things start to go up, up, up very fast, and we're past the inflection point. This means that things are going to change dramatically now, and they will be more and more visible to the public because, as I've mentioned before, a lot of AI up to now is invisible. I mean, we use it all day, every day, but it's less visible than a humanoid robot that can respond to you both verbally and watch what you're doing and react to your visual cues. This is a whole new ballgame. So thanks. Hope you enjoyed this. Please subscribe and share and like these videos. Thanks a lot. Take care. Bye-bye.